Balaya Shantaram sir and our beloved controller of examinations, Dr. Veereshan sir, to today's event, National Energy Conservation Day 2022, which is organized by Institute's Innovation Cell of CVR College of Engineering in association with Department of EEE and H&S. National Energy Conservation Day is celebrated every year on 14th December to promote energy efficiency and conservation nationwide. Hence, we are here to promote this year's message, conserve energy today to make brighter tomorrow. Now, I'll hand over this mic to today's guest. Sir, will speak on. Before that, I'll read out brief biodata and request Padmapriya Madam to hand over bouquet. Welcome you, sir, to our college and department. Balaya Shantapuram, sir. Yes, sir. Briefly, I will introduce. Balaya Shantapuram, sir, has done his BTech in Mechanical Engineering from JNTU in 1976 and post-graduation in Mechanical Engineering from IIT-CVRCoE in 1978. He is having more than 4 decades of experience in the areas of design and detailed engineering, project engineering, project management of boilers and combined heat power plants. He is a fellow member of the Institution of Engineers, life member and secretary of the Institution of Plant Engineers, IIPE, AP and TS chapters. Director, Center of Plant Engineering Services. I extend my warm welcome to our today's distinguished chief guest, Engineer Balaya Shantaram sir, and our beloved controller of examinations, Dr. Veereshan sir, to today's event, National Energy Conservation Day 2022, which is organized by Institute's Innovation Cell of CVR College of Engineering in association with Department of EEE and H&S. National Energy Conservation Day is celebrated every year on 14th December to promote energy efficiency and conservation nationwide. Hence, we are here to promote this year's message, conserve energy today to make brighter tomorrow. Now, I'll hand over this mic to today's guest. Sir, will speak on. Before that, I'll read out brief biodata and request Padmapriya Madam to hand over bouquet. Welcome you, sir, to our college and department. Balaya Shantapuram, sir. Yes, sir. Briefly, I will introduce. Balaya Shantapuram, sir, has done his BTech in Mechanical Engineering from JNTU in 1976 and post-graduation in Mechanical Engineering from IIT-CVRCoE in 1978. He is having more than 4 decades of experience in the areas of design and detailed engineering, project engineering, project management of boilers and combined heat power plants. He is a fellow member of the Institution of Engineers, life member and secretary of the Institution of Plant Engineers, IIPE, AP and TS chapters. Director, Center of Plant Engineering Services. He has worked in reputed engineering organizations at various functional levels from design engineer to vice president in various companies like TCS, Mumbai, Thermax, Babcock, Wilcox, Pune, Craft Industries, Pune, Thermal Systems, Hyderabad, and Enmass Process Technologies, Chennai, Bajaj Hindustan Limited, Noida. He received valuable training in the design of high-pressure boilers from foreign collaborators, namely Babcock and Wilcox, USA, and Ferdinand Lurgi and Babcock of West Germany. Welcome to our college, sir.
Thank you. Just keep it in there. Let's speak. They formed like called ECBC, that is Energy Conservation Building Code. Those who are in civil, they know National Building Code is there, which specifies certain directions, certain rules for designing buildings. That is the old standard. But after that, from energy place, idea is that the government level, they are putting in efforts, bringing the legislation and rules and regulations in industrial as well as the domestic commercial building area to minimize energy consumption. So when government is doing it, government may announce the pass the act, but announce regulations. But unless individually we are committed, it will not happen. We will not achieve our goals, right? So that's why energy conservation, is it a social and is it not social and citizens' responsibility? Is it our responsibility or not? Yes. So that's why. But then what is happening? What happens in our social attitude? Normally, what will happen? What is happening? It is very direct. The moment you talk about energy conservation normally in society, people think about it as a dry subject and not taking it seriously. This is what is happening. And there is a misconception that conservation is sacrificing a trunk. So conservation means, energy conservation means you are cutting down these things and all that. Don't use AC, don't use hot water. No, not like that. So there is a conception that energy conservation means cutting down on your comfort level. It is not so. It is not so. Right? Then middle class does not take much interest in this electricity because government policies are there, free power and lower tariff to the people. So why they will bother? So because of those things, they are not worried about consumption because they are not paying single paisa also. No? For example, they are farmers, even the middle class, the lower class people, their power is coming, they are free of cost to them. So they will not worry. But at the same time, they also do not have proper information. So they are not bothered because it is coming free. But does not mean that you can just consume energy like anything because of the higher consumption, greenhouse gas emissions are increasing. It is affecting globally everyone. So if we can understand that, then we use basically how much we require, that much only we use it. And here, rich people, they think that we can afford to consume whatever we want. And for example, air conditioner. So you set it to 18 degrees and then use the blanket. You are utilizing energy like that. So rich people, these are the problems. So all of you are future citizens. All of you need to understand all these aspects and see that you take proper steps to conserve the energy. Now, we talked about conservation efficiency, right? Now, when we talk about emission, zero carbon, that means you are not emitting any greenhouse gas emissions. Towards that, always, first step in this is energy conservation. That means you are using only where it is necessary. You are only using energy to the extent that is required. Below that, it is not possible. That much only. But at the same time, whatever energy you are using it with efficient equipment. Right? The first step is conservation. For example, you have to do some activity. So that requires energy. So first thing you will do is that conservation point of view, how much of that activity is required, whether to do that activity or not, now or whatever it is there. And if you have to do that activity, whatever implements that I am using, tools or whatever it is, implements you are using, am I using efficient implement so that they can reduce the power energy consumption. So base is energy conservation, next is energy efficiency. Okay. Now you have come to you understood, you avoided wastage and you are using efficient equipment. So that requires the amount of power. That power can come from sources, fossil fuels like coal, oil and all that, which is going to emit greenhouse gases. Instead of that, can I use renewable energy? For example, can I use solar energy? There are so many alternatives available, wind power and solar energy, so many things are there. But what is immediately available is solar energy is available. So can I set up solar energy, solar panel for heating or as well as electricity? So if I can use renewable energy for that, then I am taking a step to reduce the greenhouse gas emission, right? So this three-step process can help you to go towards zero carbon efficiency. That is, conservation is the best, efficiency is the next level. Third is using the renewable energy to the extent possible. Now this just 2 days back, amendment has happened to the Energy Conservation Act. They have mandated that buildings as well as certain buildings, not all buildings, buildings as well as conserving and use the efficiency. Now if you see that energy conservation, for example, the bottom, for example, you see, taking care, there are so many things. Now let me say, here, you can see domestic area. For example, pump sets are there. Normally we use in our areas pumps. What do you do? First of all, you are not using a very big pump. Whatever is your requirement, for example, 2 HP pump is there. Suppose if 1 HP pump can do your work, instead of 2 HP, use 1 HP. Right? Then matching the required head end. Suppose even 1 HP, you can have a pump which meets your just requirements to reach the top. That's all. Not necessary to have high. Then you can use pipelines which are PVC pipelines rather than GI pipelines. GI pipelines are having higher friction, so thereby it consumes more pump power. If you are using PVC lines, the lower friction, it will reduce. So like this, we can take for example. For example, suppose total consumption is 100 kilowatts, right? In that, there may be 2-3 equipment which is consuming 50-60 kilowatts, other may be 20 kilowatts, or other may be 1 kilowatt, half a kilowatt like that. So your focus should be on the equipment which is consuming more power. So you will identify those things. See, these are the opportunity for you. You imagine yourself to be an operational maintenance engineer in a company. In that case, you will be looking at this way. So then you have identified opportunities for improving energy efficiency performance. So then look at that. For example, you have identified that the particular equipment, it is consuming out of 100 kilowatts, consuming say 60 kilowatts. It is a major this thing. Then you focus your attention on that machine. Are there any new technologies available? And why it is consuming more? First of all, when you purchase the machine, the manufacturer has given you that it will consume this much power. That means it is designed for that. First of all, is it giving you that much consumption or is it taking more? If it is taking more, why it is taking more? That could be due to variation in the inputs, variation in the operating conditions. So how you can optimize those things to bring down to the design value. Okay, design value is there. Maybe that's a particularly you purchased it as an old design. Latest technologies come, new designs have come. So can I replace that machine with a new technology machine? Thereby I can bring it down from 60 to 40. Like that, your responsibility, you can utilize that opportunity and reduce the energy consumption. Now, this is called energy management, right? So what you call to achieve and maintain optimum energy procurement, generation, utilization throughout the organization. Not only utilization, production also. Minimize energy costs, waste without affecting production and quality, minimize environmental effects. At the same time, you have to see that environmental effects are also minimized. Then, optimize the energy use. How? First of all, measure and benchmarking. As I said, benchmarking is what? Design. When you purchase it, manufacturers given you, it will consume this much. That is the benchmark for you. So, you are looking at the benchmark, you optimize that. Then, availability of more energy efficient technologies, as I said. Then, reduce cycle time by eliminating non-value adding items. So, if, for example, it is taking 1 hour, say, different processes are involved in a product manufacturing. So, total time is there may be certain waste steps may be there. So, you can reduce that wastable steps and reduce the cycle time. Identify areas of losses and plan methods to reduce the losses. Reuse waste, harness waste, replace higher forms of energy with low power. So that is, you minimize the waste. Wherever, suppose, what happens, suppose you in a process plant,